compound interest, but before that let me explain simple interest. What is the basic difference between the two? Now let us consider a sum of money, suppose rupees 5,000, okay, which is lent out at the rate of 10% per annum. Per annum means per year, SI, okay. So the SI for the first year, okay, this is equals to principal into rate into time by 100. So the principal we have taken 5,000 multiplied by 10 into for first year to time 1 year divided by 100. So we get rupees 500, okay. Similarly the SI for second year remains the same, 500, okay. The SI for third year, here also the simple interest remains the same. You know why? Because the simple interest is calculated always on the principal sum. This is the principal sum, the sum of money that has been lent out, okay. Now if you want to calculate the SI for 3 years, okay, then this comes to principal into rate into time by 100. So here the principal is taken 5,000, the rate is taken as same 10%, but the time period for 3 years it will be 3 divided by 100. So it comes to 1,500 rupees. Well, this 1,500 is exactly equal to the SI for 3 years. You can see over here. Now let's compare the compound interest. The compound interest for the first year, okay, this is for the first year we are calculating. This is equals to, on the same principal we are taking 5,000, but this time the rate of interest is 10% per annum calculated as per the compound interest, okay. Now the CI for the first year, this is equals to 5,000 into 10 into 1 by 100. Well, this is the same figure, that is 500. So the CI and SI for the first year is same. But from second year onwards, the compound interest is calculated on the amount that is due at the end of first year. That means first you have to calculate the amount for the first year, okay. Let it be A1, okay. Now you know amount equals to principal plus interest. So the principal is 5,000 and the interest is 500. So it comes to 5,500, right? Now the CI compound interest for the second year, this will be calculated on this principal, okay. That means the amount due at the end of first year will become the principal for the second year, right? So the principal will be taken as 5,500, but in case of here the principal was same for the second year, same for the third year, but here the CI compound interest is calculated for the second year on this, not on the original sum 5,000. So applying the formula, this is the principal for the second year, 10% rate the same is going to be, and time period is 1 year. Second year does not mean 2 years, it's only for 1 year. So here we have 550. Now look at the difference. The CI for second year, here it is 500 SI, but this is second year 550. Again, the amount for second year, that is A2, the principal will took as 5500, right? And the interest came as 550. So it comes to 6050. This is the amount at the end of second year. Now, if you want to calculate the CI for third year, C3, then this will be calculated on this. So every year, whatever is the amount at the end of second year, that becomes the CI for, the principal for the third year. Okay? That means the CI for third year will be calculated on this, not on this particular sum. This is how the difference between the compound interest and simple interest. So the CI for third year will be 6050 into 10 into 1 by 100, and this comes to 605. Okay? Now, just compare the CI for 3 years and the SI for 3 years. So, here the CI for 3 years includes the CI for the first year, that is rupees 500, CI for the second year, that is 550, and the CI for the third year, that is 605. So, here we have 500 plus 550 plus 605. So altogether it comes to 1655. Look at this sum and this sum. So this is the basic difference. This is the expression, this is the method to calculate the CI for every year, okay, using the method of SI. But this can be calculated using formula also. Okay. Now, this particular expression, what you get? Suppose if the question asks amount for third year, okay, then whatever we took the principal for the third year, 6050, to that we are going to add the SCI for third year, that is 605. So it comes to 6655. Okay. Now, these questions, the questions asked in this type of calculations will be, there will be breakup questions like CI for first year, amount for the first year, then CI for the second year, amount for the second year. For those type of questions, you need to break up the steps like this. Okay. Now, this was the method of calculating the CI without using formula. Now, for calculating the CI using formula. Now, first and foremost thing, you have to know the expression for calculating the amount. Okay, amount can be calculated in case of compound interest for first year, second year, third year, or for n number of years. Using this formula, amount at the end of n years, this is equal to principal 1 plus R by 100, that is rate percent, to the power n. Okay. Now let me clarify what all these terms are. AN is the amount at the end of n years. N years means it could be 2 years, 3 years, 1 year. And P is the sum of money. Okay. N is the time period in months, in years. Okay. And R is of course the rate percent per annum. Per annum. Annum means per year. Okay. Now let's clarify the results over here which has been displayed. This is the method to calculate the CI amount without using formula. Okay. By method of SI. Now here we are going to calculate the amount for the first year. The amount for the first year as it is displayed is this much. Okay. So let us calculate by using formula. A equals to P 1 plus R by 100 to the power n. Okay. Now here the amount for the first year equals to, principal is 5,000, 1 plus rate is 10%. Since the time is 1 year, so it is power 1. So it comes to 5000 into, this is 11 by 10. So we are getting 5500. This is the same result what you got by breaking this into two steps. First we calculate the CI for the first year. Then we calculate the amount using the formula principal plus CI. Okay. So this is the expression what we got here using the formula. Similarly for 2 years, okay, we can calculate the formula 5000 into 1 plus 10 by 100 to the power 2. Why 2? Because this is the amount at the end of second year or amount for 2 years. So definitely the time has to be in 2 years, right? So this comes to 5000, 1 plus, this cancels, so it is 5000 into 11 by 10. Since it is raised to the power 2, we are going to multiply again 11 by 12 into 11 by 10. So the calculation comes to here 6050. So this is the figure what we got in the fourth step. So we can apply using the formula like this. Clear? Now there are special cases of here. The standard formula is to calculate the amount. Okay? Principal 1 plus r by 100 to the power n. Okay? Here this is applicable if the rate of interest is r% per annum compounded annually. Okay. Now supposing if the rate percent is r% per annum compounded semi-annually. Semi-annually means half yearly. Then the expression becomes like this. A equals to P 1 plus, the rate is going to be half because it is semi-annually. Semi-annually means half yearly. So it is 1 plus r by 200 to the power 2n. Why 2n? Because in 1 year there are 2 half years. So the power will be doubled. Okay. So here if the rate percent is r% per annum, okay, compounded, that means calculated half yearly or semi-annually. Okay. Third, if the rate percent is r% per annum, okay, compounded, that is calculated half yearly, okay. If the rate percent is r% per annum compounded quarterly, okay, then the expression for amount will be P 1 plus r by 4 into 100, because in 1 year there are 4 quarters, so the rate will be calculated 1/4 per quarter if r is the rate percent per annum compounded quarterly. Okay, and the time will be written 4 times, 4 into n. Why? Because in 1 year there are 4 quarters, so the time will be written 4 times. Okay, so these are the expressions which are special cases of this particular formula. So don't expect always you are going to apply this formula. Depends. Read the question properly. If the rate percent is r% per annum compounded annually, then this is the expression. if the rate percent is R% per annum compounded half yearly or semi-annually, then the rate will be reduced to half, the time will be doubled. Okay. Similarly, if the rate percent is R% per annum compounded quarterly, then the amount will be principal 1 plus R by 400 to the power 4n. Okay. Sometimes we have the expression, suppose in the same formula P equal to 1 plus R by 100 to the power n. Okay. There might be questions, for example, the time period will be, suppose 1.5 year. Okay. Then in this condition you have to break up this question. Then the amount for 1.5 year will be like this: A equals to P 1 plus R by 100. This is for 1 year. Okay. This will become the principal for the following year. Following year means remaining is half year only. So you will write like this: 1 plus R by, because it is half year, the rate will be reduced to half. So it will be R by 2 into 100. Okay. This is for 1.5 year. This is the amount. Similarly, if the time period is 2.5 years, okay, then the amount, this is all for the condition that the rate of interest is R% per annum compounded annually. That means this is very important to read the question. If the rate percent is R% compounded annually, only for this particular condition, okay, when it is calculated fractional years, fractional time periods, say 1.5 years, 2.5 years, then you have to break up the question like this. Now, if the time period is 2.5 years, okay, the amount will be pre 1 plus R by 100 2. That means the whole number is 2 years, fractional number is half year. So this will be the principal for the following period. That means for half year. So it will be 1 plus R by 2 into 100. Why? Because for the remaining half year, the rate will be half. Okay. So this is the expression for 2.5 years, right? This is the expression for 1.5 year. Okay. And both the conditions we are simply mentioning that if the rate of interest is R% per annum compounded annually. Okay. We were discussing till now the expression for finding the amount using the formula. But what about the compound interest? Here for first year we calculated, for second year we calculated, for third year we calculated. Now if you want the amount, okay, and the CI for n years, that means for 2 years, 3 years, like that. First step, okay, say you want to find the amount for 2 years, okay, and the compound interest for 2 years. So let me tell you, if the principal was 5,000, rate of interest 10% per annum, the compound for 2 years came as 500 plus 50, 550. So it is 1050, right? So the CI for 2 years, this means CI for first year plus CI for second year, okay? So this comes to 500 plus 550. That amounts to 1050, right? So the same result we are going to get using the formula. Now look at this. Here we have to find, the question is find the amount for 2 years and CI for 2 years. Please pay attention. It is CI for 2 years, not for second year. Okay. Now here we are taking the question, the same principal, the same rate, but the time is for 2 years, right? Now step 1, you calculate the amount for 2 years using the formula P1 plus R by 100 power 2. Okay. So taking the principal 5000, rate of interest 10% and time 2 years. So it comes to 5000 11 by 10 into 11 by 10 because the power is raised to the power 2. So this comes to 6050, right? So this is the amount for 2 years. Now what about the CI for 2 years? This is equals to amount for 2 years minus original principal. Okay, the original sum of money that has been lent out. So it comes to A2 minus P. So A2 is what you got, 6050 minus the principal 5000. So it is coming 1050. I hope it's clear. We got the same figure without using formula, applying step 1, step 2, step 3. At the end of second step, we got the amount. At the end of third step, we got the CI for second year. Upon adding CI for first year and second year, it came 1050. And the same result you got here. So these are the two steps using the formula to find the amount and the CI. Okay. Now students, we are going to discuss about some advanced level questions, and this is specially recommended for class 9 students. Okay. Suppose you are given the amount for second year, okay, A2. This is given as, suppose, rupees 1210, okay, and the amount for third year is given to you, that is A3, rupees 1331. Then you have to find the rate of interest and the principal. Okay. Remember, these type of questions when successive amounts are given. Successive amounts means second year, third year, fourth year, like that. You take the higher amount as the amount, okay, and the lower amount as the principal, and apply the formula A3 equals to A2 1 plus R by 100. The time difference you put it over here, right? So A3 is known to you 1331, second year 1210. Then you can find the rate of interest, right? So transfer this over here because this number is multiplying. So it comes to 1331 by 1210, which is equal to 1 plus R over 100. Okay. So it comes to now 1331 by 1210. Subtract 1 from here because this can't be added since R is missing. That comes to R by 100. So it is 1331 minus 1210 by 1210, which is R by 100. Okay. So here we have 1, 2, 1. This is 1. Here we have 2, and this is 1. So it is 1 to 1 by 1210, that is R by 100. Okay. Now we can cancel this 0. So 121 R equals to 1210. So R comes to 10%, right? Now using this rate, you have to find the principal. Okay. So apply the formula, take the lower amount. Now amount for second year equals to P1 plus R by 100 to the power 2. Okay. So put the value of amount A2, that is 1210. This is equals to P, that is missing, 1 plus 10 by 100 power 2. So P, this is 11 by 10 to the power 2. 1210. Now apply the cross multiplication. So P equals to 1210 into, this is 100 into 100, 10 into 10 divided by 11 into 11. Okay, 11 it cancels 110 times, then we have 10. Okay, so the principal comes to rupees 1000. Okay, so this is the way we can solve if it is successive amounts, right? Now suppose we are given A4 and A2. The same method, you can find the rate of interest first and then the principal. This time you are going to apply the formula A4 equals to A2 1 plus R by 100. The time difference is 2. So you can manage this equation. A4, A2, you put the value just as you used over here and then you can find the rate. After getting the rate, you can work out for the principal using the lower amount. That means A2. So this is how successive amounts, questions on successive amounts can be solved. Okay. This is case 1. Okay. Now let's apply case 2. When successive CI given, okay, then what to do? Suppose you given CI for first year, CI for second year, okay, and you have to find the rate of interest, principal. Okay, exactly the same method you apply. Take the higher compound interest as in place of amount, that is C2, and this is C1, 1 plus R by 100. Okay, the time difference is 1, so you can solve for R. This gives you the value of R. Okay, and after knowing the R, you can apply the lower compound interest for first year, that is P into R into 1 by 100. Use the value of CI over here. Rate you have already known. Okay, then you can find this principal amount. Okay, so this is how we can solve questions based on CI if the successive compound interests are given. Similarly, if you know for CI for second year and third year, you can apply the formula C3 equals to C2, 1 plus R by 100. Okay, and after that you can use the formula for CI for second year. Now how to use CI for second year? Okay, this expression will give you the rate of interest. Okay, and this expression CI for second year equals to amount for second year minus amount for the first year. Okay, now break up this. P1 plus R by 100 power 2 minus P1 plus R by 100. Okay, so this comes to CI for the second year. Okay, now put the value of CI for second year. This is for second year. Okay, and you can use this expression to find the principal. I can make it more simple. Take P1 plus R by 100 common. Now what is left? Here we have 1 plus R by 100 minus 1. So these two get cancelled. So your simplified expression is P1 plus R by 100 into R by 100. Okay. Now the expression is clear. This gives you the principal, that is the sum of money, and this expression gives you the rate of interest. Right? If the rates of interest are different, okay, for the successive years. For example, R1 for the first year, R2 for the second year, similarly R3 for the third year. Okay, then what you need to do to find the amount for 3 years? See, the rate is not fixed for all the successive years. Till now we have been discussing that the rates are same. Okay, here the first year the rate is R1%, for the second year it is R2%, for the third year it is R3%. So amount for 3 years if you want to find out, then we have the formula A3 equals to P 1 plus R1 by 100 into 1 plus R2 by 100 into 1 plus R3 by 100. In this way it continues. Okay. So this is the expression to find the amount when the rates are varying. Okay. Now case 4, we are coming to growth and depreciation. Okay. In case of growth, we use the formula amount equals to P 1 plus R by 100 power n. Okay. In case of depreciation, this is for growth, right? In case of depreciation, we use the expression amount equals to P 1 minus R by 100 to the power n. So depreciation means the rate is decreasing. Okay. That means in these questions the amount will be less than the principal. Okay. But in case of growth, the amount will be more compared to the principal. Right? Let us discuss a question on depreciation. Now what happens if growth and depreciation both are given? Well, let us come to this question. First year there is R1% growth. Second year there is R2% depreciation. Then in this case the formula will run as follows: amount equals to P. For the first year it is growth, so you are going to put 1 plus R1 by 100, and for the second year it is depreciation, you are going to put 1 minus R2 by 100. So in this way the questions will keep on getting calculated for successive years. So please make sure in case of growth you have to add the rate. In case of depreciation you have to subtract this. That is the difference between growth and rate. Now one question based on depreciation. The population of a town, okay, this is suppose 90,000 in the year 1975, okay. This is the population, right? And the growth rate is not given. The depreciation rate is given. Depreciation rate is given. The depreciation rate is 10% every year. Here also depreciation is 10%. Okay. Now what you have to find in this question? You have to find the population in the year 1974. Okay. 1 year back. Okay. 1 year ago. So what was the population in 1974? You have to find this. And what was the population in 1976? This is also missing. So what you have to do is that, you know that the principal sum is depreciating. That means the population 1975 was less than 74 and the population 1976 is less than this. Because every year it is decreasing. Depreciation means decreasing. Okay. Now a very simple concept. As I told you earlier, the amount keeps decreasing compared to the principal in case of depreciation. Okay. Here what you need to do is that for this part, okay, you take the population in 1975 as the principal, right? And what it shall become after 1 year, that is 1976, you take this as amount. So here the amount is missing, the principal is given. So applying the formula A equals to P 1 minus R by 100 power 1. Okay. So the population 1975 will be taken as the principal, that is 90,000. 1 minus rate percent 10% to the power 1. So it comes to 90,000 into 9 by 10, and that comes to 81,000. Okay. Once again I am repeating, for finding the amount after 1 year, okay, in case of depreciation, we have taken the population 1975 to be the principal and what it becomes after. See, amount always comes after principal. So that is how we are considering. So for the 1975 year, the population is taken as the principal for this part, second part, when you want to find the population in 1976, a year after that. So we have taken the question for depreciation as we have worked out over here. Okay. Now let us find what was the population 1974. You know, the population 1974 is the principal for this particular change. Okay, this will be the amount because what it comes after is the amount on what it was, that is the principal. So for this question, the formula will remain the same. Normally what the students do, for 1 year back, they take it as this much. No, it's not growth. It is definitely the depreciation. So the population in 1974, considering to be P, the principal amount, we are using the same formula for this part. Okay, time is 1 year because from 1974 to 1975, the time period is 1 year. So amount 1975, this will be the amount. So place it over here, 90,000 equals to P 1 minus 10 by 100. So it comes to P because P is missing. This is 9 by 10. Okay. So the P comes to 90,000 into 10 divided by 9. So it is 10,000. So P comes to 1 lakh. Okay. This was the population 1974. Now let me prove it using the concept of percentage. Now here, if the population 1974 was 1 lakh, if the population depreciates by 10%, okay, 10% of 1 lakh is 10,000. So reduce 10,000 from this, you get the amount, that is the population 1975, which is perfect, 90,000. Again, 10% of 90,000 is 9,000. You deduce that amount, 90,000 minus 9,000, it comes to 81,000. So it's absolutely perfect that in case of depreciation, again and again I am telling you are going to use this formula. A equals to P 1 minus R by 100 to the power n. Amount keeps depreciating every year. Okay.